Okay, so this is a what we call a free fall problem. Okay, so it's an object moving only under the influence of gravity. And in that situation here, the ball's thrown up. It has an acceleration, and the acceleration is downward. Okay, and we know that that acceleration is going to be equal to minus g. Okay, so it's going to be 9.81 meters per second squared. Okay, and when we do that, usually we're defining up to be positive. Okay, and so g is negative since it's pointing downwards like this. Okay, now let's take a look. If we were to graph this motion here, let's say time and distance, let's say y. Okay, the ball, it says determine the time of flight when it returns to its original position. So we're dealing with something that's going to look like this. Okay, so it's symmetric motion. And so that gives us a variety of different ways to think about this particular problem. Okay, and so I'm going to show you a couple of ways that we can approach this one. All right, so the first way we can approach it is by thinking about the position, okay, and use Optimus Prime. Okay, so Optimus Prime here is going to be delta y vi delta t plus 1/2 a delta t squared. Okay, and what we know is our initial velocity here is 15. Okay, but that's the only thing we really know, except that we also know, of course, the acceleration due to gravity. Okay, now, what do we know about position? Well, we know it goes up, it comes back down. In Optimus Prime, remember the delta y term there, whatever our delta is the total displacement from start to finish. Okay, so we started here, we went up, we came back, we ended here. So our total displacement in this case is 0. Okay, that's 0. All right, now let's put in our numbers. Okay, so v sub I, I've got 15 meters per second times t plus 1/2 minus 9.81 meters per second squared t squared. I'm going to drop the delta just because it's I'm having a hard time with my pen here. Anyway, there we go, and we can solve for that. We can that one actually can be done by hand without too much trouble. Or you could just put it into your calculator. It doesn't matter to me. Just make sure that you indicate what you're doing. Okay, so you get this far and you say, used calculator or something like that. But once you do solve for t, what you're going to end up getting here is like 3.058 something or other seconds. So when we turn that into the proper sig figs, we get 3.06 seconds. Okay, just like that. All right, now, as is often the case with kinematics problems, there can be multiple ways to get at them. So let me show you another way to work this one in case Optimus Prime didn't occur to you right away. Maybe initially you thought, oh, well, I've got some initial speed here, which is 15, and by the time it gets up to the top, my final speed is going to be 0. Okay, so what we could learn then is we could figure out, well, what's the time of flight there? Okay, and in order to pull that off, we would use SAM. Okay, SAM to the rescue again. So V final, V initial, plus A delta t. Okay, we're going to solve for delta t. So our delta t becomes V final minus V initial over A. Okay, put in some numbers on this thing, and we're going to have V final is 0 minus 15 meters per second. It's our initial. And gravity is minus 9.81 meters per second squared. Okay. And that's going to give you a number. It's going to give you like 1.53. Okay, just like that. And that's just half of our flight. Okay. So in other words, that number 1.53 gets you to this position right here. Okay, so there's our 1.53. Okay, from here to here. We got to do that again. So we would just double it. Okay, and once we double it, then, okay, 2 times our delta t, we're going to end up with the 3.06 number, just like that. Okay, so a couple of approaches there on that one. All right, another nice example of constant acceleration. Okay, things to watch out for, you know, make sure you take care to put negative in here like this. Okay, just like that. So again, we've talked about this before back in physics. All right, our acceleration, whoa, that's not the right thing. Our acceleration is minus g. Okay, now g itself is a positive 9.81. Okay, so it kind of like pi. You might have negative pi, which would mean you'd say minus 3.1415992. So I think it's 29. Anyway, like that. Okay, so always treat g itself as a positive number, and put a negative in front of it depending on, you know, up or down or however you need to there. Okay, there we go.